Yeah. So I started the recording also, and I started the YouTube live streaming also. That I done. So I think we have 2 minutes left before starting.
Yeah, okay. I just optimizing the resolution at this very moment.
Right.
Okay, it's done.
Okay. Yeah, just we have just 1 minute or more, then we will start actually.
Excellent.
I think you can start now.
Thank you so much.
Okay.
Then good morning, good afternoon, good evening to everyone, depending where you are. Today's lecture is about capturing representation and inferring context information. The first block is about capturing and representation of context information. And in order to get you involved in this common thinking, I decided to play a video at the very beginning. And through playing this video, I would like to show you what a difference knowing the context can make. So I leave the presentation material for a moment, and I go into the movie and I start playing the music. So this was it. Hope you found it interesting, because it tells a lot about the role of context. Because in this particular case, if it would have been known in advance that actually this lady just used hand gestures for remote control of her TV, and there was nothing else behind, then all these things couldn't happen. So I hope that this movie, this a little bit playing movie, is a kind of evidence that context really can play an important role in human decision making. And when I said it, I have to add immediately that obviously this is the case with smart systems, because if they are aware of the context in which they have to act or make decision, then they can do it much better. So Let's start our journey around the context. And first, let me talk about the phenomenon of context. Humans rely on and use explicit and implicit situational information at acting and talking with others. This captures the context, which increases the conversational bandwidth and improves the comprehension of the intent behind action. Processing context information makes it possible to produce more useful computational services by cyber-physical systems. Content management is needed, and it boils down to information engineering, information to eventually to decision making and problem solving. Context is traditionally descriptive, but can be also prescriptive and forecasting. This is what I would like to present in the second part of the presentation. Allow me please 1 second, because there is a technical problem seemingly here with the screen management at this moment. I have to stop sharing and I have to. So now I would like to go back to sharing and go further with the presentation. So if we are talking about context, then the context by definition means a set of things, factual or circumstantial, that surrounds and forms the setting for a particular object, an event, a situation, a statement, or an idea, or many other things. So managing context means being attentive, paying attention to the circumstances in terms of which the above things should be seen and can be partially or fully understood. These are those definitions of context which I believe are most relevant for us. Context has constituents. It is not one thing, it is a formation of many things. When we want to capture the sense of context, we can start out from a global world. Within this global world, we can define n number of local words. In every local word, we have to assume that there are entities, infinite number of entities. Obviously, we will not be able to handle all of them, but a limited n number of entities. What is important that the context management assumes that there are reference relationship between the entities. If you pick up one particular entity, it may have a multiple relationship with other entities. And the relationships are obviously can be very varied in this local world. We can apply the view of the context for all the entities. So not only this one, this one, this one, this one, all has its own context in the discussion. So anything which is inside the local word is referred to as explicit context information. But we have information outside the local word, and this is called implicit context information. And the implicit context information can manifest in things like objectives, history, mental models, and so on and so on. If we want to know more about the context, first of all, we have to see that there are many synonyms which are carrying similar meaning, but not exactly the same. These are, for instance, situation, circumstance, condition, factor, environment, surrounding, state of affairs, and so on and so on. Context is reflexive, as you have seen from my previous figure. it is also reflected on one particular entity, and it is characterizes that entity. The context typically answers questions like who, what, when, why, where, how. And if we consider these questions, actually you can build up the content of the context model. I have to emphasize the fact that context exists outside and independently of the content matter. So the content related to one entity or captured by one entity is not overlapping with its context information, the set of context information. Context can be concrete or abstract, or as I mentioned earlier, it can be explicit or implicit. There is a kind of problem with the dynamism of the information content included in context model, namely that the context may change variously, and sometimes a emerging new situation may not fit into that particular context model what we generate. So then the question after that may be with you that how to use context in the practice. And we have to consider this here, what has been already experienced, that a oversimplified context processing is useless. You need to have sufficiently rich context model in order to make meaningful decisions or meaningfully decide on the action. However, if you overdefine the context, it is first of all a procedural challenge because it takes time, it takes effort. The other thing is that it not necessarily provides a better description of the surroundings, the environment, the context in a sense than a medium complexity context model. So towards building context model, first of all, we have to elaborate on the context information. Context information can be sorted into four fundamental categories. The first one is the static context information. The second is the class of altering context information. The third one is dynamic context information. And the fourth one is emergent context information. You may feel that here there is something with the time, namely that how fast the things are changing. If you consider static context information, then robust information structures are related to that. And typically, they can be completely static, I mean perpetual, or may not change at all. This is, for instance, when you describe this road system here, and if you want to use it for guiding autonomous vehicles, this will not change. This is the same. It might be that there is an accident somewhere, but then it is not anymore in the static context category, but in the emergent context category. If there is a jam somewhere here, it goes into the dynamic context information category. The altering context information changes over a substantial period of time, and it has significant and lasting influence. Sometimes we refer to it as seasonal, for instance, the winter and the summer. These sort of changes should be considered. The dynamic context information, however, changes as a much higher space and in actually a short-term window, short time window. The situation as it changes has strong influence on the meaning and on the circumstances. This is, for instance, a traffic situation, which is definitely should be captured as a dynamic context for a automatic or an automated car. And obviously, whatever can have or happen here is a dynamic phenomenon. Emergent contexts are rarely happening, unpredictable situations, and it is very difficult to forecast that what sort of influence, what sort of consequences they have, and sometimes their interpretation is even uncertain. Just consider, for instance, a kind of crash or fall of a bridge as a kind of emergent situation, and then you have to do something here, for instance, to rescue people with the cyber physical system, then you really need this sort of context information. So far, so good. We identified 4 sources of context information, but obviously context information is not falling down from the sky. There are actually physical sources for them, and one of them is the information which is produced by hardware sensors. They can be signal sensors, like pressure sensors, environment sensors, like video camera. But we can have also sensor networks, so multiple sensors producing information for us, and it can be a homogeneous sensor network or can be heterogeneous sensor network. The homogeneity or heterogeneity means that here similar type of sensors are included, or the included sensors are addressing the same phenomenon where it is not standing clear. Sensor raw data are typically massive, heterogeneous, and variable. For these reasons, we have to do something with it in order to use it as context information. Different technologies are available to pre-process sensor data. One of the major actions is to reduce the amount of raw data for context modeling, because as I mentioned, although an exhaustive description of the context would need infinite pieces of information, however, we are not able to capture it, or if capture a large part of it, we are just causing processing difficulties. So for this reason, somehow the raw data should be reduced, and it can be reduced, for instance, techniques like sampling, averaging, patterning, sensor regime scaling, or variance over time. When we have data from multiple sensors, and if we want to merge it in the sensor, in the context model, then we have to fuse the sensor data. So actually, this fusing means that integrating the information from multiple sensors with a particular objective. Typically, 3 types of fusion approaches are available, sensor data fusion approaches. The first one is the competitive fusion, the second one is the complementary fusion, and the third one is the cooperative fusion. Since each of them starts with the letter C, often it is referred to as the triple C technique. Going into the details, C1 combines sensor data representing the same measurement used on certain ranges of conflicts using weighting average of the fusion function. Then complementary fusion combines incomplete sensor data that do not depend on each other directly to create a more complete model. So it is a kind of complementing action what is done here. And then the cooperative fusion combines sensor data that depend on each other to produce higher level measurement by fusion functions such as, for instance, the classical merging, Bayesian merging, fuzzy merging, the Dempsey-Schaeffer theory of logic, and so on and so on. Then, if we have this sort of fused data, then we can continue with building our context model. However, we have to see that there is multiple views of context model. And one of them is the representational view, and the interactional view is the other. There are assumptions for both which are different. Assumptions for the representation view is that the context is a form of information, form space, something stable and separable from activity. Implications that the context can be described using a set of appropriate observable attributes. So it is a kind of reductionist approach if you consider. Limitations, permanent and generic attributes prevent handling situated action. The interactional view places more attention to the action. The assumption is that it is a form of relation, and there is a activity which establish or which establish this relationship, or activity actually manifests based on a relationship, and it can be dynamically changing. And opposing the representational view, it says that it is inseparable from the activity. Implications are that there is a cyclical relationship between the context and the activity, and the limitations are that intentional context is not observable and needs abstraction. These are the things what I extracted from the paper of Duris, which was published in 2004. Representation view, actually, what I mentioned earlier, or important things. In addition to that, it is important for us to know that that the context what we can have is obviously a non-exhaustive specification of the model, and nevertheless, we can use this context information and to represent it as explicit enumerated set of static attributes, which creates a kind of extensional view on it. Context information should be processed before reasoning, and then the contextual variable may have semantic implications, which are obviously difficult to process. For instance, those sort of implicit meanings, like when we are talking about Sunday, implicitly everybody knows that we are talking about the weekend. So the representational view raises the extensionalism versus intentionalism issue. Could you please switch off the microphones, because I thought that my other application was running, but I again hear the same noise. Thank you so much. So the interactional view is more intentional. The context exists usually implicitly in relation to the ongoing interaction of the user with the system, and it is not static. Contextual is a relational property that is the same, or some information may not be relevant to some activity, and the relevance of the context may be space, time, meta-context dependent. And obviously this raises the need for dynamic context management and frequent evaluation of the activities in the context. So when we are talking about the context model building, then I have to talk about the contextual variables, which are actually vectors, and we refer to these vectors as contextual conditions. We can make a kind of composition of the context variable, and in this case, each component may have additional structure. For instance, they may have a tree structure or a network structure, and so on and so on. And then when we create a context model, actually every context variable is a node in that hierarchical context model. For instance, here is an example, a purchase context, and composed with temporal context. these are a node in this particular context model. Obviously, a contextual variable may have a rather varying content. For instance, here, as you can see, work and weekend, it means that purchasing something for work on a weekend is the contextual condition, what is described here. Then contextual relationship, what I mentioned, exists. They can be static associations, varying associations, or derived associations. And we can characterize these associations. For instance, here I show a concrete model, and here you can see that there is an association between the person and the activity, and this sort of relationship is characterized by the probability, the certainty, and the accuracy, and so on and so on. And this is how we characterize the association. And obviously, these associations can be used, for instance, as rules in context reasoning. This figure is just a kind of visual image that what should we think of. So there are contexts, typical contexts, which are related to human. For instance, the physical context, time, position, activity, weather, light, temperature, artifact, environment. Social context, the presence and role of other people around the person. Modal context, the state of mind of a person, personal goals, moods, experience, and cognitive capabilities. Interaction context, the device, use, the type of media, and so on and so on. So what I wanted to show with this particular slide is that that it seems to be easier to create a context model for non-human type of entities, but the creating the context model is much more challenging and sophisticated for human beings. So when we are talking about the model development, we can identify stages of processing context data. And then I also already mentioned the concept of raw context data. It can be converted, as I mentioned, with different technologies into filtered context data. And the filtered context data is, which is actually the basis of the working context data, because the working is a subset of the filter, working is what goes into the actual context model. Then we can identify different types of context awareness, what we can consider as developing our context model. For instance, there are personalized context awareness, active context awareness, and passive context awareness. And we also have to consider that there are certain criteria for developing good high-value context model. For instance, comprehensiveness, deviations, ambiguities, specification, and quality metrics are the most important things. In this last slide, before finishing the blog, I included actually different type of context features and a list of different context modeler systems. These commercially available. And then here you can see that what their capabilities are. So if you want to deal with context representation, context modeling, context inferring, please look around on the internet, figure out first what these systems are able to do, and then make a wise choice. As always, here is my suggested literature related to this book. I would like, first of all, to refer to above a seminal paper towards a better understanding of context and context awareness. This is really a kind of Bible for every one of us. Then another paper, Engineering Context Aware Systems and Applications Survey, is very important state description. Then Boccioni paper, a data-oriented survey of context model, also useful. Bettini and co-authors wrote a survey on context modeling and reasoning techniques. And finally, Adam Marius presented a paper which is titled Incorporating Contextual Information in Recommender Systems Using the Multidimensional Approach. So this concludes, please, the first block of the presentation. I stop screen sharing, and I would like to kindly ask you if you have any. Oops.
Any questions? Anything you want to ask?
Hello, sir.
Yes.
Yeah, we will.
Yes, sir. In case of machine learning or deep learning, we need huge amount of data so as to process it. For example, the sensor data in the form of images or the data. So if I'm having less amount of data, for example, I'm having images like in numbers 500 or 1000 images, and I want to apply machine learning or deep learning so as to get desired output. So is there any method to enlarge the data with the existing one? One means by scaling it or flipping it, likewise means can we do some data augmentation to enlarge the data to increase the number of sample sizes from the sensor?
If I understood your question correctly, you were asking about the augmentation opportunity of data. Is it?
To enlarge the number of data samples.
Yes. So, and which data, sorry, sir, I have to ask, which type of data are you talking about? Raw data, filtered data, or working data?
The data is actually in the form of images. Yes, sir.
So the raw data, what you receive. Very, very interesting question, but maybe you will be surprised that it is not a simple situation, because, for instance, if we have data streams and we know that there is a kind of time stamping on the data, then, for instance, we have the opportunity to iterate between two measured data which have been taken at the same time. Do you understand is what
yes,
I'm saying? So, to the data stream, pick two data which are taken at the same time and try to interpolate, try to see what is the middle, the average or whatever, or the geometric average or something. These things are possible. These are known in the literature. But the problem is with the, let's say, the semantic-free extension, because obviously the data in itself is just a number of a value or whatever. The meaning makes it useful for us. So if you want to have data which are reflecting a meaning, then obviously you have to have the sensor for it, because otherwise you cannot generate that data. So for instance, if you have a electric motor, and let's suppose that the electric motor is overloaded, and everything is described here in the context model, except the external temperature, which influences the final temperature, the heating temperature of the motor, right? So if you don't have sensor for the ambient temperature, if you don't have a sensor for the motor temperature, I personally don't see opportunity to generate this semantic information for your context model. So in a nutshell, in certain cases, simple cases, we can do something for the enrichment and augmentation of the incomplete or insufficient data, but there are no universal rules for that.
Okay.
Every case should be treated separately on its own. That's what I can comment on. Thank you for the question, and I do appreciate, as always, your contribution, because really you are following the presentation, as I see, with a very, very open mind. Thank you so much.
Thank you, sir. Thank you. Clear, sir.
Since the time is running, I believe we have to go to the second part of the presentation. The recording is on, I guess.
Yeah, it is on. You can start this.
And then I go to the presentation material again. And I continue with the second block. Please give me a confirmation that you can see the screen.
Yeah, it is.
So it will be a kind of follow-up on the question of the kind colleague, because it is about how to infer semantic context information. So how to enrich. If we have a basic set of information, what can we do with it? How can we use it more semantically rich? This is the major issue here, what I want to talk about. And then, obviously, the goal is to make cyber-physical system context-aware based on processing context information. And this is why we are dealing with context model development. And this is why we are believing that if we have context model, the information provisioning and service provisioning to the user of the system can be better. There are, however, some fundamental questions. For instance, how to acquire context information. You heard about it. I believe that context information should be based on physical or cyber sensors. How to model context information. I already sketched it up very briefly. You can find other papers, even books, which explain this story. And then how to process dynamic context information. This comes now. And how to reason upon context information. This is also an important aspect of the discussion in this book. And how to provide the most attractive services is something what later on we will address. So don't forget the main phases of getting to context model is context acquisition, the actual model development, and reasoning based on the existing model. So context-aware computation is a term which is actually in the existent in the literature for more than 20 years. And the context-aware computation is an approach which aims at using constant or changing context information in content modeling. So together with the content modeling, the content model, for instance, in case of the cyber-physical system, is a system operational model, or the content control model. These are content models which use context model. Context computation can be static or dynamic. A context-aware software, by definition, is an application that changes or adapts its behavior dynamically based on real-time or real-life context information. A context-aware system can automatically change the form of its services and context change, and as the context changes. It provides its services as the values of the information that characterizing the servicing, the services is changing. Context-aware CP architecture is an important aspect what I would like to present you, namely if we have an ambient environment with a human observer who is collecting context information, from this can be ambient variables and situation variables generated, which go into the context modeling, and then the context modeling creates a POSIX context model. Just consider, for instance, a narrow and a broader context model here. And then there is a actual context, a information content, I hope not confusing you, what can be processed. And then obviously, this is used for the adaptation of the context-based application in the model. And this is how we get to the application model, application domain. And this is how we can feed the specific application with content and context information simultaneously. The POSIX contexts are formal models, so they can be subject of data management. You can store them and take them out and you reuse them, or you can take them out, modify them, adopt them, and reuse that way. So actually, also there is a kind of activity related to the context-aware operation of cyber-physical system, which is a context-based data tailoring process. Hope this model is clear for you. So there are different types of context-aware systems that I would like to briefly elaborate on. First of all, we have reactive type of context-aware system. And this system provides immediate context-dependent results in response to a user-initiated request. For instance, this is a recommendation during the search for a point of interest with a smartphone. Or we can have proactive context-aware systems, the systems autonomously, without explicit user request, deliver context-dependent information and another the user interface based on the context. An example for it, a kind of collision avoidance system which is working like this. But if you just consider this collision avoidance system, then immediately you have to see that the proactive context-aware system, which tries to avoid the collision, interrupts the user activity, while the reactive context-aware cyber-physical system don't do that. Important is to sense the trick and interpret complex situation to act in a non-disturbing manner. This is what we have to consider in the development of cyber-physical systems. So then I mentioned or previously the sources of context information. I don't elaborate too much here on that. More importantly, the context information, which actually we are also using, I briefly elaborated on it previously. So the identification, the spatial and temporal and attribute context information representing the primary sets, and there are secondary sets of context information, for instance, activities, influential factors, and different constructions, arrangement, designs, and there are tertiary context information, for instance, anything which is implicit, the intentionality, the objectives, the roles, the beliefs, and so on and so on. So, here something popped up, because I would like to go towards the inferring from the context information models, and I would like to show you how it is happening. And this is just a kind of theoretical prelude, a theoretical introduction that what is the logic, what is the principle behind, or what can be one of the principles behind inferring from context model and complex context information sets. So most probably for most of you, the classical knowledge pyramid is known. I apologize for this animation error here. I don't know what happened this morning. I didn't see it here. Maybe I interacted negatively. Okay. So the classical knowledge pyramid actually means two things. First of all, syntactic aggregation and semantic inference, semantic abstraction. This is how we work on the knowledge pyramid. On the lower level, there is a phenomenon. This phenomenon might be described with indicators or directly with data, but the indicators are introduced in order to be able to generate data. The data, the meaning of the data is the information. If the information is integrated and abstracted, then it provides knowledge which makes you active. And then if the knowledge is aggregated, filtered, and synthesized, this is a kind of experience that leads you to the wisdom. So this is how the classical knowledge pyramid is working. And we can apply the same as a underpinning theory for processing context information. Because we can have purposeful context information, purposeful positions, combinations of the context information, and then we can impose semantic abstractions on that. I will show you how to do it later. So here the starting point is the signal flow, and the signal flow is actually manifest in data streams which are conveying featured data. This featured data can be taken out as information. If we interpret the features and we see what sort of data are describing these features, then it is a piece of information or a set of information. Then based on the information, we can create based on rule-based reasoning or using machine learning or deep learning or whatever technologies, we can extract semantic patterns. When these semantic patterns get interpreted and put into application context, then we can talk about operative knowledge, or as we call it, working knowledge. The working knowledge aggregation, synthesis, and abstraction leads to a better knowledge, and this all together forms the intellect of the system, of the next generation cyber physical system. And this is why we are talking about intellectualization of these cyber physical systems rather than making them intelligent, as several authors in the literature refer to. So this is the hierarchy of the basic notions, and this is how we can develop a mechanism for abstracting semantic information from lower level context representation model. So inferring on the knowledge pyramid, you remember that I said aggregation and abstraction is the major thing, and we go over these sort of levels as we discussed it. But we need to identify what are the constituents, what we can use from a context model for this sort of inferring or reasoning purpose. First of all, we have entities. Here, these O's as objects are indicated. Then the entities are characterized by attributes. Here is the indication. So there is an attribute vector here, and different numbers of attributes may be characterizing a particular sorry for this intermezzo. So different number of attributes may be characterizing a entity. If we have the entity, then we can say that the entities are always in a particular state. The state may be non-existing as well. So if the state exists, however, in that case, we can describe the entities in that state with the respective sets of attributes. Now, if we have the states, the changes of the states causes a event. Just consider, for instance, that riding a bike is a state, then bumping into by another rider is also a particular, riding by another driver is also a state. And then these two come together, they can create an event. So the changes, I should say, the mutual changes of states may result in events. And then when we have the events and we combine the events, then we can have situations. And then the situations combination can result in scenes. So this is that sort of pyramid what you can build up. And again, if the attribute is changing, it means that the state is changing. If the states are changing, then they may cause events. If the events are combined and interacting, then they create situations. If more complex situations are interacting, then they create certain things. We believe that with this hierarchy, with this knowledge pyramid, which is applied to context information, we can really model practically everything without limitation. And those who were present in that lecture, in which I gave a summary of the PhD project what we have developed, I mentioned fire evacuation problem. So this theoretical fundamental was used in order to make the reasoning about the evacuation plan and the informing of the involved people possible. So then what actually this inferring means if we have these different levels in the context model. So this is what was presented for you earlier. And then if we consider what we can reason out on the different levels, it is the following. So first of all, we have inferences in the attribute level. So for instance, if the attribute of an object is changed, then it is not anymore the same object. For instance, if an object a object was black and it is repainted to white, then it is a different object, for instance, from the perspective of the development of a driving strategy for a car. This is what came to my mind, because a white car better visible in general than a black car, than for instance difficult to observe during the night. So this is the first level, that the changes in the object can be reasoned out this way. Then on the actual level of the object, for instance, the cardinality is one thing. How many objects are involved? Is it increased or is it decreased? This is an elementary reasoning, semantic reasoning. So you can see that the population is increasing or decreasing, and that can be used for further reasoning purpose. But also, for instance, if because I mentioned that everything is about the relationships here, if the relationship between two objects is changing based on the attributes, because for instance the distance between them is changing, then it is also the basis of a conclusion. Then on the next level, when it is all about the state, so the state is, for instance, something like if you are on the bike, or if you are pushing the bike, or if you left the bike somewhere, and so on and so on. So based on these sort of states, which are combination of entities and their relationship, you can again make inferences. And if you go further towards the level, then the events, for instance, these sort of states are changing mutually, then maybe you can infer that something happened and most probably there was an event which caused the changes. I have to say here that obviously there is a kind of back propagation here because any time when an event happens, then you have to update, for instance, the state representation. You have to update even the entity representation because, for instance, a frozen piece may have evaporated or something like this, and also the attribute representation. But going back, because time is running fast, so actually if we come up to the level of the situation, so when multiple events are happening in the same time, for instance, cars were taking the corner at a junction and two cars came together and then it creates a situation. But though the situation is that there is a jam on other parts of the road, and then obviously it goes a scene, which means that in a particular segment of the road, these are the situations, these are the events that are happening, these are the states which we have to consider, and so on and so on. So this is how it is working in principle logically, and obviously different inferring techniques can be applied. For instance, we experience very much with rule-based reasoning, and believe me, it is contrary to the fact that it is often said obsolete and too simple for the cases. This is just because of the tyranny of the machine, the deep learning guides and whatever. Rule-based reasoning can be equally useful in situation, but you can use also geometric or image-based reasoning, when you use, for instance, videos. You can use the machine and deep learning equivalent with others. You can use probabilistic reasoning, case-based reasoning, and so on and so on. So these are the flexibility what we have at the time of developing aware cyber physical system. Situation awareness is something what we want to achieve, and Emsley describes situation awareness as a perception of environmental factors plus the interpretation of their meaning plus the projection of their status to enable decision superiority. In this viewpoint, situation awareness is essentially a top-down driven mental paradigm. It is in line with what I presented on the previous slide, and it is divided into three major components: perception, comprehension, and projection. Actually, you see, this is what we implemented because the data collection is the result of the perception. The comprehension is an interpretation of what changes are there, and the projection is projecting out to situations and scenes. There are many context learning mechanisms out there, and most of them what can be used for our purposes is the unsupervised learning mechanisms. Later on, I will talk about it. Since the time today ran faster, and I wanted to explain the concept of this sort of reasoning, I want to mention that actually the context is extremely important in the case of recommendation systems, and all the recommendation systems do have some sort of context model, and obviously here the major recommendation problem is that what are the preferences of the user and what the user wants to have, and then this sort of preferences can be coded in certain kind of context model which describes the behavior, the past behavior already learned or to acquire behavior of the user. So this is just, you can read a lot about this recommendation problem in the literature. So And the last thing what I would like to mention here, filtering of the recommendations can be collaborative filtering, context-based filtering, knowledge-based filtering, or context-based filtering. At the end, as always, I would like to show you a couple of related literature sources. For dynamic context-aware workflow management scheme for cyber-physical systems based on multi-agent system architecture is a useful reading. The job paper on overview of the explainability of cyber-physical systems also has a high value. Then there is from Down and colleague a paper, context modeling for cyber-physical system, and Fortune paper of context data management and architectural framework for context-aware services is the last one what I would like to mention. So actually, I don't know why this figure is coming out again. Most probably there is something wrong with the animation today. But what I would like to say as an epilogue is that in the first part today, we discussed the essential influence, impact, even the capturing and representation of context information. In the second book, we dealt with the modeling and inferring issues. And you can see that if you have a relevant context model, how powerful it can be and how many things we can reason out. And obviously, this last short elaboration on the recommendation systems was intended to cast light on the fact that actually reasoning by CPS do request real-time context processing, which is obviously a rather challenging thing. But also, if the cyber-physical system is a kind of recommendation system, then you have to be careful with processing the recommendations in context. So please stay tuned for the next lecture. This is finished for the time being. I shut down my presentation and I go into full screen mode if I manage. And please, I'm sorry for taking the time, but I wanted to give sufficiently comprehensive explanation on this beautiful story of context modeling, and I believe it also added something to the very good question of Mr. Vasanta. Thank you, Vijay. I'm done with these two blocks, and if anybody has questions, I'm very pleased, obviously, to take the question. I apologize, it's so warm today.
Yeah, any questions? In between, I request participant to turn on their videos so we can have a screenshot also. And if you have some questions, you can just ask.
Ladies, did you see my first video? What did you think about it?
Mandloy, Ishan Patil, Chinmay, Sunil Saket, Arun Kumar Sharma, Harshal, turn on your video, Prashant Sharma, Sunil Saket, okay. 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 Thank you very much. And then we break for the 15 minutes.
Yes, please.
Yeah.
We will start 11:45 according to my time.
Yeah, in 3:15 p.m. at Indian time we will be starting
Thank
the
you
next.
so much.
Thank you.
Have a nice rest. Until.
Okay, thank you.